Number 1. The universe is expanding faster than the speed of light. Thanks to dark energy, the fabric of space itself is expanding so rapidly that distant galaxies are being pulled away from us at speeds exceeding the speed of light. This doesn't violate Einstein's theory of relativity because it's not the galaxies themselves moving faster than light, it's space itself stretching. This also means there are parts of the universe we will never, ever see. Light from those galaxies will never reach us, not in 1 trillion years. They are forever out of reach. Number 2. Earth's atmosphere extends beyond the Moon. In 2019, scientists discovered that Earth's outermost atmospheric layer, the geocorona, extends up to 630,000 kilometers, 391,000 miles, more than 50 times the Earth's diameter. That means the Moon actually orbits inside Earth's atmosphere. This vast hydrogen cloud is so diffuse it's invisible to the naked eye and harmless to spacecraft, but it blurs the line between Earth and deep space. Number 3. Jupiter could have become a star. Jupiter, the largest planet in our solar system, is made primarily of hydrogen and helium, just like the Sun. If it were about 80 times more massive, the pressure and temperature at its core would have been high enough to ignite nuclear fusion and start burning like a star. Instead, it remains a failed star, emitting more heat than it receives from the Sun due to its internal contraction. Number 4. You can see stars that no longer exist. Some of the stars we see in the night sky may have already exploded. Their light simply hasn't stopped arriving yet. A star 1,000 light-years away could have died 500 years ago, but we wouldn't know it for another 500 years. We are literally looking into the past every time we gaze at the stars, witnessing ancient light that has been traveling across space for millennia. Number 5. Black holes can spaghettify you. If you fell into a black hole feet first, you'd be stretched into a long, thin strand of atoms in a process called spaghettification. This happens because gravity at your feet would be vastly stronger than at your head. For small black holes, this happens quickly and violently. For supermassive black holes, like the one in the center of the Milky Way, you might cross the event horizon without feeling a thing, and not know you've passed the point of no return. Number 6. Neutron stars are incomprehensibly dense. A neutron star, the collapsed core of a massive star, is so dense that a single teaspoon of its matter would weigh around 6 billion tons. That's the weight of a mountain, compressed into a spoon. Neutron stars are only about 20 kilometers across but contain more mass than the Sun. They also spin at incredible speeds, with some rotating hundreds of times per second. Number 7. The Voyager spacecraft are carrying humanity's message. Launched in 1977, Voyager 1 and 2 are now traveling through interstellar space. On board each is the Golden Record, a time capsule containing music, greetings in 55 languages, images of Earth, and scientific diagrams. These records are intended for any intelligent extraterrestrial life that might one day find them, a hopeful gesture across space and time. Number 8. A day on Venus is longer than its year. Venus takes 243 Earth days to rotate once on its axis, but only 225 Earth days to orbit the Sun. That means a day on Venus, sunrise to sunrise, is actually longer than its year. Even more bizarrely, it rotates in the opposite direction of most other planets, meaning the Sun would rise in the west and set in the east if you could see through the dense, sulfuric acid clouds. Number 9. Saturn's rings are surprisingly young. Although Saturn is over 4.5 billion years old, its iconic rings may be just 100 to 200 million years old, younger than the dinosaurs. They might have formed when an icy moon got too close and was torn apart by Saturn's gravity. Over time, the rings will likely fade or collapse into the planet, making this a brief but beautiful phase in the life of the solar system. Number 10. There are more stars in the universe than grains of sand on Earth. There are an estimated 200 billion trillion stars, 2 × 10 squared cubed, in the observable universe. That's more than all the grains of sand on every beach and desert on Earth. Each of those stars could have its own planetary system, meaning the number of planets could be even higher, a mind-boggling ocean of potential worlds. Number 11. Some stars can vibrate like musical instruments. Stars like our Sun undergo oscillations, internal pressure waves caused by energy bubbling up from their cores. These vibrations cause subtle pulsations on their surfaces. By studying these with a technique called astroseismology, scientists can determine a star's age, size, and internal composition, just like tapping on a bell can tell you how it's made. Number 12. The Moon is moving away from Earth. The Moon is receding from Earth at about 3.8 centimeters, 1.5 inches, per year due to tidal interactions. Over hundreds of millions of years, this has dramatically affected Earth's rotation and the length of our days. In the distant past, Earth rotated much faster, and a day lasted only 18 hours. In the far future, days will get even longer. Number 13. The observable universe has an edge. But the universe itself might be infinite. We can only see 46.5 billion light-years in any direction, not because that's all there is, but because that's all the light that's had time to reach us since the Big Bang. Beyond that, the universe may stretch on forever, possibly containing infinite galaxies, stars, and planets, and perhaps even infinite versions of ourselves. Number 14. Gamma-ray bursts are the most powerful explosion since the Big Bang. Gamma-ray bursts, GRBs, are so powerful they can release more energy in 10 seconds than our Sun will emit in its entire 10 billion-year lifetime. These bursts originate from the collapse of massive stars or the merger of neutron stars. If one happened close enough to Earth, it could strip away our atmosphere, but thankfully, none are currently aimed at us. Number 15. Space isn't completely cold, but it's close. Space isn't at absolute zero, but it's close. The temperature of the cosmic microwave background, the faint afterglow of the Big Bang, is just 2.7 Kelvin, minus 270.45 degrees Celsius or minus 454.81 degrees Fahrenheit. That's just 2.7 degrees above absolute zero, the coldest temperature possible. But in places like stellar cores or near black holes, temperatures can soar into the millions. Number 16. The International Space Station orbits Earth every 90 minutes. Traveling at 28,000 kilometers per hour, 17,500 miles per hour, the ISS circles the Earth roughly once every 90 minutes. Astronauts aboard witness 16 sunrises and sunsets each day. In microgravity, their bodies undergo rapid changes, muscles atrophy, bones lose density, and even the shape of the brain shifts. Number 17. Time moves slower in strong gravity. According to Einstein's theory of general relativity, time passes more slowly in stronger gravitational fields. Near a black hole or a neutron star, seconds stretch. If you lived on the surface of a massive planet, time would tick slower for you than for someone in deep space. This isn't just theory, it's been confirmed by satellites and GPS systems, which must account for these tiny but measurable differences. Number 18. There may be a ninth planet in the solar system. Astronomers suspect there might be a hidden planet, dubbed Planet 9, lurking in the outer solar system. It would be 5 to 10 times the mass of Earth and orbit far beyond Neptune, taking over 10,000 years to complete one revolution. Its presence is inferred from the strange clustering of objects in the Kuiper Belt, a kind of cosmic detective story still unfolding. Number 19. The largest known structure in the universe is a supervoid. The giant void, discovered in 2007, is a cold, empty region of space over 1.8 billion light-years across. It contains far fewer galaxies than expected and may be the largest structure in the known universe. Scientists aren't sure how it formed or whether it contradicts standard cosmology. It's so large it affects the temperature of the cosmic microwave background itself. Number 20. Break time equals 0. 5s/. Some comets come from the edge of the solar system. The Oort cloud is a spherical shell of icy objects surrounding the solar system, extending up to 100,000 Australian dollars, astronomical units, from the Sun. Occasionally, a gravitational nudge from a passing star sends one of these comets falling toward the inner solar system, where it dazzles us with tales of gas and dust, brief visitors from the ancient frontier. Number 21. A star's life cycle can last billions of years. Stars are born in clouds of gas and dust in space, called nebulae. Once gravity pulls this material together, nuclear fusion begins, creating the energy that powers stars. The length of a star's life depends on its size. Smaller stars, like our Sun, can burn for around 10 billion years, while massive stars may burn through their fuel in just a few million years. After exhausting their fuel, stars can die in spectacular explosions, supernovae, or slowly shed their outer layers, leaving behind dense remnants. Number 22. The Sun makes up 99.86% of the mass of the solar system. The Sun is an absolute giant compared to the rest of the objects in the solar system. Its mass is about 330,000 times that of Earth, and it contains 99.86% of all the mass in the solar system. If you could hollow out the Sun, you could fit over 1 million Earths inside. Despite its size, it accounts for only about 1/10,000th of the volume of the solar system. The Sun's gravitational pull keeps the planets and smaller objects in orbit around it, driving the dynamics of our solar system. Number 23. Spacecraft have traveled to the outer limits of the solar system. The Voyager 1 spacecraft, launched in 1977, has now traveled further than any other human-made object. It crossed into interstellar space in 2012, and it continues to send data back from the edge of the solar system. Voyager 1's power is expected to last until around 2030, after which it will continue drifting through space, its instruments silent, for billions of years, potentially forever. Number 24. A year on Pluto is 248 Earth years long. Pluto, the dwarf planet located in the outer reaches of the solar system, has a highly elliptical orbit. This means it takes 248 Earth years to complete a single orbit around the Sun. Interestingly, Pluto's orbit is tilted in relation to the other planets, so it doesn't always stay in the same plane as the rest of the solar system. Its orbital eccentricity means it occasionally comes closer to the Sun than Neptune, but the two never collide due to their gravitational dance. Number 25. A black hole can be created by star collisions. While black holes are often formed when massive stars collapse, they can also form from the collision of two dense stellar objects, like neutron stars. These collisions, which produce both gravitational waves and powerful bursts of gamma rays, were first detected by the Laser Interferometer Gravitational Wave Observatory, LIGO, in 2015. Such events are rare but incredibly powerful, often creating a black hole with several times the mass of the Sun. Number 26. The Moon's surface is covered with dust. The Moon is constantly bombarded by micrometeoroids, which pulverize the surface rocks and create a layer of fine dust known as lunar regolith. This dust is incredibly sharp, abrasive, and can be problematic for astronauts. It clings to everything: spacesuits, equipment, and even the lunar module. When Apollo astronauts returned from the Moon, the dust caused respiratory problems and damage to their gear, highlighting the challenges of long-term lunar exploration. Number 27. Earth's magnetic field protects us from solar winds. Earth's magnetic field acts like a shield, protecting us from the harmful effects of solar winds, streams of charged particles emitted by the Sun. Without this magnetic field, which stretches far into space, the solar wind would strip away the Earth's atmosphere, rendering life impossible. This magnetic shield is generated by the motion of molten iron in Earth's outer core and creates the stunning auroras we sometimes see near the poles. Number 28. Mars has the largest volcano in the solar system. Mars boasts the largest volcano in the solar system, Olympus Mons. Standing at 22 kilometers, 13.6 miles, high, it's nearly 3 times the height of Mount Everest. Its base spans 600 kilometers, 373 miles across, making it a truly colossal structure. Despite its size, Olympus Mons is relatively young compared to other features on Mars, and scientists believe it may still be volcanically active, though no eruptions have been observed. Number 29. Neptune's winds are the strongest in the solar system. Neptune, the 8th planet from the Sun, experiences the strongest winds of any planet in the solar system. These winds can reach speeds of up to 2,100 km per hour, 1,300 miles per hour, much faster than the speed of sound on Earth. The source of these high-speed winds is still a mystery, as Neptune receives very little heat from the Sun, which is typically responsible for driving weather patterns on planets. Number 30. There are rogue planets wandering through space. Some planets don't orbit stars. These rogue planets are free-floating worlds that have either been ejected from their parent star systems or never formed around a star in the first place. Scientists believe there could be billions of these rogue planets in our galaxy alone. With no star to provide warmth, it's believed that these planets would be incredibly cold and dark, but they might have their own internal heat sources. Number 31. The most distant galaxy known is 13.4 billion light-years away. The farthest galaxy observed by astronomers is a galaxy named GNZ11, located about 13.4 billion light-years from Earth. This means that we are seeing it as it appeared just 400 million years after the Big Bang. The light we see from GNZ11 has traveled for 13.4 billion years, meaning we're looking at the universe in its infancy, offering a glimpse into a time when galaxies were just beginning to form. Number 32. Star formation happens in nebulae. Stars are born in cold, dense regions of space called nebulae. These vast clouds of gas and dust collapse under their own gravity, and as the material condenses, it heats up, eventually igniting nuclear fusion and forming a new star. The Orion Nebula is one of the most well-known star-forming regions, containing thousands of young stars. Some of these stars are still in the process of forming, and the nebula itself is still actively creating new stars. Number 33. Our Sun has a grandchild. The Sun doesn't just influence the planets in our solar system, it also has a grandchild in the form of the Sun's second-generation stars. The atoms that make up the Sun were created from earlier generations of stars, which exploded as supernovae and seeded the cosmos with heavier elements. The Sun's formation from this stellar nursery means it's a second-generation star, and some of the elements that make up Earth came from even older stars that predate the Sun. Number 34. Saturn's moon Titan has lakes of liquid methane. Titan, Saturn's largest moon, is the only moon in the solar system with a thick atmosphere. Its surface is dotted with lakes, rivers, and seas, but instead of water, these bodies are filled with liquid methane and ethane. These hydrocarbon lakes behave in much the same way as water lakes on Earth, with rainstorms and evaporation. However, the surface temperature is around -180 degrees Celsius -290 degrees Fahrenheit, making Titan's environment vastly different from Earth's. Number 35. The Hubble Space Telescope can see back in time. The Hubble Space Telescope, launched in 1990, allows us to peer back in time by observing distant galaxies. Because the speed of light is finite, when we look at distant objects, we are actually seeing them as they were billions of years ago. The farther away a galaxy is, the further back in time we're observing. This is how Hubble has allowed scientists to look at galaxies forming just a few hundred million years after the Big Bang. Number 36. Venus' atmosphere is hotter than Mercury's. Despite being farther from the Sun, Venus has a much hotter surface than Mercury. This is due to a runaway greenhouse effect, where the thick atmosphere of Venus traps heat, preventing it from escaping into space. Surface temperatures on Venus average around 465 degrees Celsius (869 degrees Fahrenheit), hot enough to melt lead. The dense cloud cover also creates extreme pressure, which is about 90 times that of Earth's surface pressure. Number 37. A star in the shape of a guitar. In 2017, astronomers discovered an unusually shaped star in the constellation Hercules. Known as the guitar star, it has a magnetic field so strong it reshapes the star's structure. This magnetic field is much stronger than that of the Sun, and it bends the star's plasma into a guitar-like shape, making it one of the most unique objects in space. Number 38. The Earth's core is hotter than the surface of the Sun. The Earth's core, made mostly of iron and nickel, is estimated to reach temperatures of about 5,500 degrees Celsius (9,932 degrees Fahrenheit). This is hotter than the surface of the Sun, which hovers around 5,500 degrees Celsius (9,932 degrees Fahrenheit). This intense heat is responsible for the generation of Earth's magnetic field, which shields us from solar radiation and helps maintain life on our planet. Number 39. Some black holes are spinning space itself. Rotating black holes, or Kerr black holes, do more than just bend space and time, they can drag space around with them. This effect, called frame dragging, creates an ergosphere, a region where space itself is twisted and dragged around the black hole. In theory, you could escape a Kerr black hole if you avoided the event horizon, though once inside, all paths lead inward. Number 40. Time dilation has been measured on airplanes. Einstein's theory of relativity says that time moves slower the faster you go. This isn't just theory, it's been tested. In the Hayford-Keating experiment in 1971, atomic clocks were flown around the world on airplanes, and when they returned, they were found to be ever so slightly slower than clocks that had stayed on the ground. The difference was just billionths of a second, but enough to prove time dilation is real. Number 41. Uranus spins sideways. Uranus is tilted at an extreme angle of 98 degrees. Essentially, it rolls around the Sun on its side. This bizarre orientation might be the result of a massive collision with an Earth-sized object long ago. Because of this tilt, Uranus has the most extreme seasons in the solar system, with each pole getting 42 years of continuous sunlight, followed by 42 years of darkness. Number 42. The Sun rings like a bell. Just like stars, the Sun vibrates due to pressure waves rippling through its interior. These waves cause oscillations that are not visible to the naked eye but can be detected using instruments on solar observatories. These solar quakes help scientists study the inner structure of the Sun in a field known as helioseismology, unlocking secrets about its rotation, density, and magnetic fields. Number 43. Shooting stars aren't stars at all. The beautiful streaks of light we call shooting stars are actually meteoroids, small chunks of rock or metal, burning up in Earth's atmosphere. They usually come from comets or asteroids and enter our atmosphere at speeds up to 70 kilometers per second, 43 miles per second. Most are the size of a grain of sand, but when they strike the atmosphere, they release enough energy to create a glowing plasma trail. Number 44. Galaxies can collide, and we're headed for one. The Milky Way is on a collision course with the Andromeda Galaxy. In about 4 billion years, the two galaxies will begin to merge in a cosmic ballet. Despite containing hundreds of billions of stars each, the space between stars is so vast that very few will actually collide. Instead, the gravitational interaction will warp and reshape both galaxies, eventually forming a single elliptical galaxy. Number 45. Lunar eclipses can turn the moon blood red. During a total lunar eclipse, Earth moves directly between the Sun and the Moon. Rather than going completely dark, the Moon turns a deep red. This happens because Earth's atmosphere scatters blue light from the Sun but bends and passes red light onto the Moon's surface, the same effect that makes sunsets red. This eerie phenomenon is sometimes called a blood moon. Number 46. Break time equals 0. 5s/ Earth is the only planet not named after a god. All the other planets in our solar system are named after Roman or Greek gods: Mercury, Venus, Mars, Jupiter, etc. But Earth simply comes from the Old English and Germanic words meaning ground or soil. In Latin, it was terra, and in Greek, Gaia. Our home planet is unique not just in name but in the life it supports, at least so far as we know. Number 47. Pulsars are cosmic lighthouses. Pulsars are rapidly spinning neutron stars that emit beams of electromagnetic radiation from their magnetic poles. If these beams sweep past Earth, we detect them as repeating pulses of radio waves, hence the name. Some pulsars spin hundreds of times per second, and their timing is so precise they rival atomic clocks. They are being studied as potential navigational tools for future interstellar spacecraft. Number 48. There might be a multiverse. Some theories in cosmology suggest that our universe may be just one of many, and a multiverse. In some models, each universe might have its own physical laws, constants, and even dimensions. This idea is not yet proven, but mathematical implications from inflation theory and quantum mechanics leave room for the possibility that reality extends far beyond our cosmic horizon. Number 49. The vacuum of space isn't completely empty. Space might look like a vast, perfect void, but it's never completely empty. Even in the most barren reaches, quantum fluctuations constantly cause particles to pop in and out of existence. This vacuum energy is predicted by quantum field theory and may play a role in the mysterious force we call dark energy, which is accelerating the expansion of the universe. Number 50. You could fly through Saturn's rings. Saturn's rings look solid from afar, but they are actually made up of countless individual particles, mostly ice, with some rock, ranging in size from tiny grains to car-sized boulders. They are so thin, only about 10 meters thick in most places, and so spread out that a spacecraft can pass through them without damage, as Cassini did multiple times during its mission. Number 51. Galaxies rotate like giant pinwheels. Galaxies like the Milky Way rotate at tremendous speeds, with their stars and gas orbiting the center in organized motion. However, the outer regions of galaxies rotate just as fast as the inner regions, something that shouldn't be possible based on the mass we can see. This led to the discovery of dark matter, an invisible substance that makes up about 85% of the universe's mass and exerts a gravitational pull. Number 52. Moons can have moons, in theory. While no moons, also known as submoons, have been observed yet, there's nothing in physics that forbids a moon from having its own satellite, provided it's far enough from its planet and not pulled away by gravity. Some simulations suggest that large moons, like Saturn's Titan or Jupiter's Ganymede, could theoretically host submoons, though they may be unstable over long periods. Number 53. The James Webb Space Telescope can see the birth of stars. Launched in 2021, the James Webb Space Telescope, JWST, is the most powerful space observatory ever built. It uses infrared light to peer through thick clouds of dust and gas, allowing us to see stars being born, something that was impossible with Hubble alone. It can also analyze the atmospheres of exoplanets, potentially identifying signs of life. Number 54. Break time equals 0. 5s/solar storms can disrupt Earth technology. The Sun occasionally releases massive bursts of charged particles in events called coronal mass ejections, CMEs. When these particles hit Earth's magnetic field, they can disrupt satellites, knock out GPS systems, interfere with radio signals, and even overload power grids. The largest known solar storm, the Carrington event of 1859, caused telegraph systems to catch fire. A similar event today could cause global blackouts. Number 55. The universe is fine-tuned for life, maybe too fine. Some scientists point out that many physical constants, like the strength of gravity or the charge of the electron, fall into extremely narrow ranges that allow for the existence of stars, planets, and life. If they were even slightly different, the universe might be lifeless. This has led to the fine-tuning problem and philosophical debates about whether this is chance, design, or the effect of a multiverse. Number 56. The Kuiper Belt is a realm of frozen relics. Beyond Neptune lies the Kuiper Belt, a vast region filled with icy bodies left over from the formation of the solar system. Pluto, Haumea, Makemake, and Eris are among its most famous members. The Kuiper Belt is similar to the asteroid belt but much larger. It stretches from 30 to over 50 Australian dollars from the Sun. It's believed that many comets originate from here. Number 57. Earth wobbles as it spins. Earth doesn't spin perfectly, it undergoes a slow wobble known as axial precession, caused by the gravitational pull of the Moon and Sunday. This wobble completes a full cycle roughly every 26,000 years. It causes the positions of stars to shift slowly over millennia and means that the North Star won't always be Polaris, it changes over time. Number 58. A day on a neutron star lasts milliseconds. Neutron stars can rotate at incredible speeds. The fastest known neutron star, PSRJ 1748-2446 AD, spins 716 times per second, meaning a day on its surface lasts less than 1.4 milliseconds. These ultradense remnants have immense magnetic fields and gravitational forces, and if you stood on the surface, hypothetically, you'd weigh billions of tons. Number 59. The Moon has quakes. Just like Earth has earthquakes, the Moon has moonquakes. These can be caused by meteorite impacts, tidal forces from Earth, or even thermal expansion as the Moon's crust warms and cools. Some of these quakes, recorded by seismometers left by Apollo astronauts, were strong enough to register at magnitude 5.5, and they can last for up to 10 minutes due to the Moon's dry, rigid crust, which doesn't absorb shock well. Number 60. Gravity can bend light. According to Einstein's theory of general relativity, massive objects like stars and black holes can bend the path of light around them. This phenomenon is known as gravitational lensing. It allows astronomers to detect galaxies and objects that would otherwise be hidden behind brighter ones, essentially using the universe's own mass as a cosmic magnifying glass. Number 61. The Drake equation tries to estimate alien life. In 1961, Dr. Frank Drake formulated an equation to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way. It factors in things like star formation rate, the fraction of stars with planets, the number of planets that could support life, and more. Though many of its variables remain unknown, the Drake equation has become a foundational concept in the search for alien life. Number 62. The Sun will eventually become a white dwarf. In about 5 billion years, the Sun will exhaust its hydrogen fuel and expand into a red giant, engulfing Mercury, Venus, and possibly Earth. After shedding its outer layers in a planetary nebula, it will leave behind a dense, Earth-sized core or a white dwarf. This remnant will shine faintly for trillions of years before eventually fading into a cold, dark, black dwarf. Number 63. Mars has giant dust storms that can last for months. Mars is known for its colossal dust storms, some of which can grow large enough to engulf the entire planet. These storms are driven by solar heating and can last for weeks or even months. During the 2018 global dust storm, NASA's Opportunity rover lost contact due to lack of solar power and was never heard from again, bringing its 15-year mission to an end. Number 64. Black holes can merge in cosmic collisions. When two black holes orbit each other closely, they lose energy in the form of gravitational waves and gradually spiral inward until they merge. These mergers release massive amounts of energy and distort space-time itself. In 2015, scientists detected the first such wave with LIGO, opening a new era of gravitational wave astronomy, letting us hear cosmic events for the first time. Number 65. Jupiter's Great Red Spot is a gigantic storm. Jupiter's Great Red Spot is a massive, persistent storm system larger than Earth. It has raged for at least 350 years, possibly much longer, with wind speeds reaching over 400 km per hour, 250 miles per hour. Recent observations suggest it's shrinking, though the reason why is unknown. Still, it remains the solar system's most famous storm, a swirling, rust-colored reminder of Jupiter's dynamic atmosphere. Number 66. A single satellite failure could trigger a chain reaction. A theoretical scenario known as Kessler syndrome suggests that if one satellite breaks apart, its debris could collide with others, creating more fragments and a cascading effect. This orbital debris field could render some altitudes in space unusable. It's one reason agencies now monitor space junk closely and why deorbiting retired satellites has become a priority. Number 67. The universe might be flat. Based on cosmic background radiation and large-scale observations, scientists believe the universe is geometrically flat, meaning that parallel lines never meet, and the rules of Euclidean geometry hold true on a cosmic scale. This has profound implications. A flat universe suggests it will continue expanding forever, albeit at an accelerating rate, rather than collapsing or cycling endlessly. Number 68. Saturn could float in water. Saturn, despite being the second largest planet, is mostly made of hydrogen and helium, giving it an average density lower than water. If you could find a bathtub big enough, Saturn would actually float. Of course, this is purely hypothetical, but it shows how wildly different the gas giants are from rocky planets like Earth. Number 69. Humans can see the Andromeda Galaxy with the naked eye. Despite being 2.5 million light-years away, the Andromeda Galaxy is visible from Earth without a telescope in dark, clear skies. It appears as a faint, elongated smudge in the constellation Andromeda. It's the farthest object you can see with the naked eye, and a glimpse into the universe beyond our own galaxy. Number 70. Some planets rain glass or lava. On exoplanets like HD 189733b, the weather is nightmarish. This hot Jupiter has temperatures over 1000 degrees Celsius, 1800 degrees Fahrenheit, and winds that blow over 8,000 kilometers per hour, 5,000 miles per hour. Even more terrifying, it rains molten glass sideways. Other exoplanets, like 55 Cancri e, may have rivers of lava and no atmosphere to block the hellish heat from their stars. Number 71. Cosmic time capsules exist. When we look at distant galaxies or stars, we're literally seeing into the past. The Hubble Deep Field Image, for example, captures galaxies as they existed up to 13 billion years ago. Because light takes time to travel, distant objects act like cosmic time machines, preserving snapshots of ancient eras that no longer exist in the present. Number 72. There are over 8,000 active satellites in orbit. As of mid-2025, there are over 8,000 functioning satellites orbiting Earth. From weather monitors to GPS units to Starlink communication satellites. Thousands more inactive or broken satellites remain in orbit as space debris, posing an increasing risk of collision. This has led to global debates about space sustainability and the creation of international tracking networks. Number 73. The Tunguska event was a cosmic airburst. In 1908, a meteoroid exploded in Earth's atmosphere above the Tunguska region of Siberia, flattening over 2,000 square kilometers of forest. The object never hit the ground. It disintegrated about 5 to 10 kilometers above the surface, releasing energy equivalent to 10 to 15 megatons of TNT. If such an event occurred over a populated city, it would be catastrophic. Number 74. The Moon is slowly becoming tidally locked to Earth. While the Moon is already tidally locked, showing us only one side, Earth is also gradually becoming tidally locked to the Moon. Over billions of years, Earth's rotation is slowing down due to tidal friction. Eventually, Earth and Moon may face each other permanently, with one side of Earth always facing the Moon, but this won't happen for tens of billions of years. Number 75. Light from the sun takes time to reach you. The sunlight you feel on your skin is old, about 8 minutes and 20 seconds old, to be exact. That's how long it takes light to travel from the sun to Earth across 150 million kilometers, 93 million miles. But the photons that finally escape the sun's surface may have taken tens of thousands of years to travel from the core to the surface, bouncing around inside the star. Number 76. Some of the atoms in your body are older than the sun. Many of the heavy elements in your body, like carbon, calcium, and iron, were forged in ancient stars that died long before the sun was born. These elements were scattered into space by supernovae and eventually incorporated into the gas cloud that formed our solar system. That means you are literally made of stardust, and some of that stardust is older than our star. Number 77. Earth's orbit is not a perfect circle. Earth orbits the Sun in an ellipse, not a perfect circle. This means the distance between Earth and the Sun changes throughout the year. Earth is actually closest to the Sun in early January, perihelion, and farthest in early July, aphelion, yet seasons are caused by Earth's axial tilt, not proximity to the Sun. Number 78. Betelgeuse might explode soon, cosmically speaking. Betelgeuse, the red supergiant in Orion's shoulder, is nearing the end of its life. It could go supernova at any time in the next 100,000 years, a blink of an eye in cosmic terms. When it does, it will shine as bright as a full moon and be visible during the day for weeks. Though it's about 650 light-years away, it poses no danger to Earth, just a spectacular show. Number 79. The observable universe contains over 2 trillion galaxies. Originally estimated at around 100 billion, the number of observable galaxies has been revised upward to 2 trillion, thanks to deep field observations and improved techniques. That means the universe is not just vast, it's unimaginably populated, each galaxy containing billions or trillions of stars, each potentially with its own planetary systems. Number 80. The universe might be recycled. Some cosmological theories suggest the universe undergoes cycles of expansion and collapse, the Big Bang followed by a big crunch, or even a big bounce, where the universe re-expands after collapsing. While current observations support continuous expansion due to dark energy, these ideas remain part of scientific exploration into the ultimate fate of everything. Number 81. Time dilation has been measured on airplanes. Einstein's theory of relativity says that time moves slower the faster you go. This isn't just theory, it's been tested. In the Hayford-Keating experiment in 1971, atomic clocks were flown around the world on airplanes, and when they returned, they were found to be ever so slightly slower than clocks that had stayed on the ground. The difference was just billionths of a second, but enough to prove time dilation is real. Number 82. Earth's atmosphere glows. Even on the darkest night, Earth's atmosphere emits a faint glow called airglow, caused by atoms and molecules in the upper atmosphere that become excited by solar radiation and release photons. This isn't visible in cities due to light pollution, but from space or dark observatories, it creates a surreal, colorful shimmer, especially at twilight. Number 83. There's a molecular cloud that smells like rum and raspberries. In the Sagittarius B2 cloud, near the center of the Milky Way, astronomers discovered ethyl formate, the molecule that gives rum its flavor and raspberries their smell. This giant gas cloud is filled with complex organic molecules, hinting at how chemical building blocks of life might be common in space. It's one of the most aromatic places in the galaxy, if you had a nose and lungs that could survive there. Number 84. Stars don't really chi. Number 85. Saturn's moon Enceladus shoots water into space. Enceladus, one of Saturn's smaller moons, has cryovolcanoes that eject plumes of water vapor, ice, and organic molecules into space from fractures near its south pole. These plumes shoot hundreds of kilometers high and feed Saturn's E-ring. Beneath its icy surface lies a global subsurface ocean, making Enceladus one of the most promising places to search for extraterrestrial life in the solar system. Number 86. The Sun has an atmosphere millions of degrees hotter than its surface. The Sun's surface, or photosphere, is about 5,500 degrees Celsius, 9,932 degrees Fahrenheit. But the outer atmosphere, the corona, can reach temperatures of over 1,000,000 degrees Celsius. This paradox has baffled scientists, but recent theories suggest that magnetic waves or nanoflares might be transferring energy from below the surface into the corona. We still don't fully understand it. Number 87. Halley's Comet will return in 2061. Halley's Comet, one of the most famous objects in the solar system, orbits the Sun once every 76 years. It was last seen in 1986 and will return in 2061, brighter and more visible than it was during its previous pass. It's been documented for millennia. Chinese records mention it as far back as 240 BCE. Its return has even coincided with historic events like the Battle of Hastings in 1066. Number 88. You can hear space in a way, through radio waves. Although sound doesn't travel through the vacuum of space, radio waves do, and these can be converted into audio signals. NASA and other observatories record these emissions from planets, stars, and even black holes, and convert them into eerie, alien-like sounds. Jupiter, for example, sounds like roaring static and crackles, the music of magnetic storms. Number 89. Jupiter's moon Io is the most volcanically active body in the solar system. Io is constantly squeezed and pulled by the gravity of Jupiter and its neighboring moons, creating intense tidal heating. This causes Io's interior to melt, fueling hundreds of volcanoes, some of which erupt with plumes hundreds of kilometers high. Its surface is constantly reshaped, dotted with lava lakes, sulfur plains, and explosive geysers. Number 90. Neptune radiates more heat than it receives. Despite being so far from the Sun, Neptune emits 2.6 times more energy than it gets. The source of this internal heat isn't fully understood. It might come from leftover heat from its formation, radioactive decay, or friction caused by material falling toward the core. This internal energy helps drive its extreme weather systems and superfast winds. Number 91. The largest known star would fill Earth's orbit. Scuti, a red supergiant in the constellation Scutum, is the largest known star by radius. It's about 1,700 times the diameter of the Sun. If placed at the center of our solar system, its outer surface would extend beyond the orbit of Jupiter. It's not the most massive star, just the biggest in size. Eventually, it will explode as a supernova, possibly leaving behind a black hole. Number 92. Supermassive black holes reside in most galaxies. Nearly every large galaxy, including the Milky Way, harbors a supermassive black hole at its center. Ours, known as Sagittarius A*, has a mass of about 4 million suns. Some galaxies have black holes billions of times more massive. These monstrous objects are believed to play a crucial role in galaxy formation and evolution, regulating star formation through jets and radiation. Number 93. There's a dark side of the Moon, but it's not always dark. The far side of the Moon is often called the dark side, but that's a misnomer. It receives just as much sunlight as the side we see. It's only dark in the sense that it's hidden from Earth due to tidal locking. The far side has rougher terrain and more craters than the near side. In 2019, China's Chang'e mission became the first to land a spacecraft there. Number 94. Time stops at a black hole's event horizon, from an outside view. From a distant observer's perspective, an object falling into a black hole appears to slow down and freeze at the event horizon, never quite disappearing. The light it emits becomes more and more redshifted until it fades from view. For the falling object itself, though, time continues normally. It crosses the event horizon in finite time and is drawn to the singularity at the center. Number 95. DNA can survive in space, for a while. Experiments on the International Space Station have shown that DNA molecules can survive short-term exposure to the vacuum and radiation of space, especially if shielded by dust or meteorite material. This lends support to the panspermia hypothesis, the idea that life's building blocks could have traveled between planets or even star systems, riding aboard comets or meteoroids. Number 96. The Sun flips its magnetic field every 11 years. Every solar cycle, the Sun's magnetic poles flip, north becomes south and vice versa. This magnetic reversal is part of the Sun's 11-year cycle of sunspot activity, flares, and coronal mass ejections. During the flip, solar activity peaks, increasing auroras and potentially affecting satellites and power grids. The next solar maximum is expected in the late 2020s. Number 97. You can see satellites with the naked eye. Many satellites, especially the International Space Station, are visible to the naked eye just after sunset or before sunrise. The ISS is brighter than most stars and moves steadily across the sky in a straight line. There are even apps and websites that tell you exactly when and where to look. It's a surreal reminder that humans have machinery and people orbiting overhead. Number 98. You age slightly slower on the ISS. Because of both high orbital speed and Earth's gravity, astronauts aboard the International Space Station experience relativistic time dilation. They age just slightly slower than people on Earth. The difference is tiny, fractions of a second over 6 months, but measurable. This has even been confirmed by comparing atomic clocks on Earth and in orbit. Number 99. A full moon appears 14% larger at perigee. When the moon is closest to Earth in its elliptical orbit, a point called perigee, and it coincides with a full moon, it appears larger and brighter than usual. This is known as a supermoon. The moon can appear up to 14% larger and 30% brighter than when it's farthest away, apogee. Despite the hype, the difference is subtle to the naked eye, but still beautiful. Number 100. The universe is made mostly of things we can't see. Everything we can observe, stars, planets, gas, dust, makes up only about 5% of the total mass energy of the universe. The rest is made of dark matter, 27%, and dark energy, 68%. We don't know exactly what dark matter or dark energy are, but we can detect their influence, like how dark matter holds galaxies together, and dark energy accelerates the expansion of space. Bonus fact: at the heart of the universe's most extreme objects, time itself slows to a stop inside a black hole. Imagine floating through space, far from the familiar twinkling stars of Earth's night sky. Ahead of you, a patch of blackness looms, not ordinary darkness, but an absence of everything. No light escapes it. No signal returns from within. You are approaching a black hole, one of the universe's most enigmatic and violent objects. Black holes are the collapsed cores of massive stars, formed when gravity overwhelms every other force and squeezes matter into an infinitesimally small point called a singularity, a place where density becomes infinite and our laws of physics break down. But even before you reach this singularity, something extraordinary happens. As you draw closer, you cross an invisible boundary known as the event horizon, the point of no return. From your perspective, crossing the event horizon takes mere seconds. But to an outside observer, you appear to freeze at the edge, slowly dimming, your image stretched and redshifted into oblivion. Why? Because at the event horizon, time dilates infinitely. This is a consequence of Einstein's general theory of relativity, which tells us that gravity doesn't just pull on mass, it pulls on time itself. What does that mean? To understand it, think of time as a fabric stretched across space. Near a black hole, that fabric is warped so steeply that time near the event horizon ticks incredibly slowly compared to the universe far away. If you hovered just outside the event horizon of a supermassive black hole for what felt like an hour, millions of years could pass in the universe beyond. This is not science fiction, it's been modeled, calculated, and even observationally supported. How do we know? In 2019, the Event Horizon Telescope collaboration released the first actual image of a black hole's shadow, captured in the galaxy M87. That bright orange ring? It's the accretion disk, superheated gas swirling at near-light speeds just outside the event horizon. The intense gravity of the black hole bends the path of light itself, creating a perfect circle. Astronomers could measure the way light was delayed and stretched, providing direct evidence of gravitational time dilation. These aren't theoretical models anymore, we've seen time warping happen around black holes with our own instruments. What happens inside the event horizon? Here's where things get truly mind-bending. Once you pass the event horizon, all possible paths through space-time lead to the singularity. There is no way to avoid it. From your point of view, time still ticks, you fall toward the center and reach the singularity in seconds or minutes. But from the outside universe's perspective, you never actually enter. You are forever frozen on the brink. Even more bizarre? Causality breaks down. The very concept of before and after collapses. The singularity isn't a point in space, it's a moment in time, one you are destined to reach. A real example, Gargantua. The 2014 film Interstellar portrayed this phenomenon accurately thanks to physicist Kip Thorne's input. In the movie, the characters orbit a supermassive black hole named Gargantua. Because of its immense mass and slow spin, 1 hour near its surface equals 7 Earth years. This time dilation leads to emotional and philosophical consequences. People age, miss lifetimes, and lose the flow of the world they knew. That level of dilation is not far-fetched. In fact, at the event horizon of a rotating black hole like Gargantua, you could theoretically hover for hours while entire civilizations rise and fall elsewhere in the cosmos. So why does this matter? Because it means that black holes don't just warp space, they warp reality. They challenge our deepest assumptions about cause and effect, time and space. They force us to reconcile relativity with quantum mechanics, a task that has stumped physicists for decades. Some theorists suggest black holes may even contain gateways to other universes, or encode information on their surfaces in 2 dimensions, creating a holographic model of reality, a radical idea that could revolutionize physics. In short, the simple fact is this. Near a black hole, time slows down. At the event horizon, it stops. And once you're inside, all paths, in space and time, lead to an inevitable singularity. Yet wrapped in that fact is an entire universe of implications about time travel, cosmic death, the limits of science, and the fragility of reality itself. And the most haunting part? There are millions of black holes in our galaxy alone, and the nearest one might be just 1,600 light-years away, hiding in the dark, distorting time as we speak.